So let's move on. Find dead code and get lots of other useful feedback in your programs. So I don't know about you, but it's not a whole lot of fun, and it's not really very productive, or it's not easy to do, to go back and read your own code or read somebody else's code and try to identify problems with it, ways to improve it. So what you want to do is find ways to automate the analysis of your code. Now, Toad and SQL Navigator from Quest have their own code expert. PL SQL Developer does some of this kind of analysis. But Oracle, too, has a feature that you can now enable to automatically analyze the quality of your code. It's called the Compile Times Framework. And I'll show you an example of that. We'll look at PLW 6002. All my PLW files in my demo zip are examples of the PL SQL warnings subsystem. This is added in Oracle 10G. Okay, so what I'm going to do here is enable warnings in my session. Enable warnings. And you can enable a subset of warnings, not all, but we'll just keep it simple. So you can turn that on in your session, and it's not turned on by default. And then, when I compile my program, Oracle will automatically check to see if any of the warnings are violated. So let's run this, compile this code, and let's see what I get. Look at this. I've got PLW warnings on the bottom of my screen. PLW 6002, unreachable code. Oracle has automatically analyzed my program, and it's telling me this code will never run. Now, in this simple example, we can actually see that. L checking is set to be false. It's never true. This will never run. But of course, in our real programs, we might have whole big chunks of code lurking in our programs that never, ever execute, can't ever execute, and we have no idea that's true. So that's very cool. In addition, PLW 6006 says, hey, you've got a local module. Why did I write this? And it's never called. So not only is it dead code, but actually what it's telling us is that the optimizer has removed this code. It's actually taken it out of the compiled code since it's not needed. So that, in a nutshell, is the warning subsystem. You can go to the error messages documentation. In fact, if you go to tahiti.oracle.com, this is one of a couple of different online searchable repositories of Oracle documentation. You can drill down to any of the individual documentation sets by version, and you can look at the error messages and manual, look at all the warnings, and decide which of those are important to you to check out. But we won't bother with that now. So use Oracle's compile time warning subsystem to automatically analyze your code, give you advice about how to make it stronger, faster, better. Where did that error come from? Well, probably some of you have run into this very frustrating situation. Prior to Oracle 10G Release 2, if you handle an exception inside PL SQL, you cannot get the line number on which it was raised, which is very frustrating. And I've actually talked to developers who have designed their applications to never trap an exception in the back end so that the exception goes unhandled to the front end, a web browser environment, and they would train their users to report the line numbers in the error stack so that they could figure out where the problem occurred. That's just ridiculous. And that's the way Oracle is sometimes. But fortunately, in 10G Release 2 and higher, you now can get that information with the backtrace function. So let's take a look. So first of all, just to prove my point that you can't get the error information if you handle it, I'm going to create this stack of calls. 3, calls 2, calls 1, raises an exception. And if I let this exception go unhandled, which is what we'll do first, then in fact, we do see the trace back to the line number on which the error occurred. That's what you see here. This is something you'll see in SQL Plus and Toad, et cetera. This is information that's been available through the OCI or C code layer forever. But if I trap the exception inside PL SQL, which is of course what I want to do, and display, for example, the error stack, which is really the same thing as the error message, that's all I get. I see an error message, but I will not be able to see that line number. That really stinks. This is all I see. So what you can do is in your back-end code, you can put in a call to format error backtrace. I can trap it inside PL SQL. And then if I display that error information, I will now see the error trace. Here it is. So this is now available in PL SQL. The backtrace function, format error backtrace, should be called in every single exception handler you have in your application. But unless you've taken the right approach to writing your exception handlers, that's going to be a terrible situation to confront. And I talk a lot in my class not only about format error backtrace, but the DBMS error log package, other error mechanisms. And I also talk about how to build a single shared utility that will allow you to do this much more easily. And in fact, I show you how to use one that I have built and make available for free. Okay, and last topic for this, and then we'll see if there are any questions. Functions without return statements. Now, I bet you've all had situations where you've run into this error. Function returned without value. This is kind of an embarrassing error. Let me show you that one. I'm going to show it to you by the warnings subsystem because it's something that Oracle will warn you about. Here's a function that has one path that does not return. And if I execute this function, I get this error. And like I say, I think this is really embarrassing. It's such a badly designed function, it doesn't even execute a return statement. And again, you can actually ask Oracle to tell you through warnings that you've got a problem with this function. That's great. But what I want to show you is a function that doesn't have to have a return statement at all, and it's not only perfectly valid, but it can make your code run a lot faster. And these are pipelined table functions. Now, this is going to go really quick. This is a pretty tough, complex topic. We actually have about 20 pages in the 5th edition of Oracle PL/SQL Programming that focuses just on this one feature, written by, not me, but an expert in the topic. But just to give you a basic sense of the weakness of the pipeline table function. The basic idea with the pipeline table function is that it returns data from the function asynchronously to the termination of the function. In other words, while the function is still running, it's returning data back. This is important in parallel query and other environments. Here's an example of a pipeline function. I've taken some data. It's actually, I pass a select statement to my function, and I return a nested table. And in the non-pipeline version, I will put information in that nested table and return it. In the pipeline version, when I'm ready to get some data and pass it back, I just use the pipe row syntax to send it back to the calling query. And because of that, when my function is all done, it doesn't have to return anything but control. So what my table function could have in it is a return statement like this, return semicolon, just return control. But actually, it turns out, I can define the package without any return statement at all. Oracle says, no problem, I'll compile it, and it will run it without error, which is really strange, but very cool because this can improve performance dramatically. Just to give you a quick sense of that, this is actually another technique for improvements of order of magnitude or more. Here's an example of using my pipeline table function in a streaming table function environment. This is something that you do in a data warehouse kind of environment where I'm doing in-line, in SQL transformations of data. I'm going to take data from one table, a select statement, pass it as a variable to another function, select from it, do some transformation, select from it, insert into another table. And what I'm going to do is add where row num is less than 10. It's actually going to transform 100,000 rows to 200,000 rows, but I only need the first 9. And I'll do it with a pipeline version and a non-pipeline version. And the difference in performance is really quite amazing. On Oracle 9i at least, right? It gets better in some of the later releases. In fact, here we'll just look at 10G. When I used pipelining, it took me 0.1 seconds to retrieve the first 9 rows. When I did it without pipelining, it took almost 4 seconds because it actually did all 100,000 rows, transformed them into 200,000 rows, and then returned those 200,000 rows, which only the first 9 were used. With this approach, as my pipeline table function is running, it's returning the rows of data. And when the outer query gets the first 9, it says, hey, I'm done. And it stops the function. Very interesting, very non-standard behavior in the world of PL/SQL, something you will want to check out. Okay, so isn't PL/SQL just amazing? Look at all that great stuff you can do. So, of course, ideally, the outcome of this webinar would be that you knew all the stuff, you didn't learn anything new, and you should congratulate yourself on being a very advanced PL/SQL developer. You're staying on top of the technology. My experience, however, is that many developers do not know about this technology, or maybe have heard about it but have never actually done anything with it, don't know about the ins and outs and the gotchas. And if that's the case, maybe you should consider joining me on January 26, 27 in Boston. So that's the end of my teaser presentation. Now let's see if we have any questions.
Great, Stephen. Thanks. We do have a couple of questions in the queue. The first one is back to the bulk collection demonstration you did, and then you added the limit clause, and Alwar Sami asks, when you use limit bulk collection, is the performance still the same, or is it slower?
So that's a great question. When I'm using bulk collect, when I'm using bulk collect with limit, do I still get the benefits of performance? So let's bring up the example script. And the answer is absolutely. Now, so you see here bulk collect limit 1,000. Let's change it to 100. If you read Tom Kite, and I'm sure you all do, Tom actually recommends that you always use a limit clause of 100. That you can set it to 500, 1,000. It doesn't seem to matter. The performance is always the same. And that's largely been my experience as well. But so I would say in general, number one, you do get the same boost in performance essentially. There might be some minor differences, but again, if you can't afford to allocate all the memory with a single bulk collect, you've got to use this approach, and you will see the benefits in performance. Second of all, and a limit of 100 is probably fine. I would actually make it a variable or a parameter, like bulk limit in. It doesn't have to be a literal. And then you can change the limit clause without changing your code. When you start to work with really large amounts of data, like that one example I mentioned, the 25,000, the 2 weeks to 20 minutes, she found that a limit clause of 25,000 was the most efficient for her. So you can play around with it and see which works best for you. But by and large, setting the limit to 100 will likely be good enough, and you will still see an incredible benefit.
Great. And another question. This was regarding the result cache. When is the memory used with the function result cache released?
So when is the memory for the result cache released? So the idea behind the result cache is it's actually stored in the SGA. That's why it's not quite as fast as PGA-based caching, but it is shared across all sessions. The result cache will retain its memory for as long as the database instance is up and running, unless for some reason the cache needs to be invalidated. For example, if my cache depends on a certain table, and then I make a change to that table, anybody makes a change to that table and commits the changes, the cache is automatically invalidated. Also, the DBA can invalidate the cache through the DBMS result cache package. And finally, if my cache isn't big enough to support all the data that's being queried into it, or put into it through the result cache keyword, then Oracle will cycle the old data out using the least recently used algorithm. So if and when you start to use the result cache, you need to work with your DBA and make sure it's sized properly so that you're not thrashing the data in and out of the cache. Otherwise, it's really not doing you much good.
That's great. Thanks, Stephen. And Stephen, if you could just bring up that SkillBuilders.com SF page so they could see that, that'd be fantastic. Another question in the queue from Ben. I'll field this one. Ben asks, I'm an Oracle certified SQL expert, but a novice at PL SQL. Any recommendations as to where to begin to learn PL SQL? I'll throw my 2 cents in on this one. Then we have a whole calendar of classes on the SkillBuilders website. If you're interested in online learning, instructor-led two-way online learning, you can just sign up on one of these classes, and you will receive the best of training from one of our instructors. What you're seeing now is the Steven Feuerstein 2-day class in Needham, Mass. That class is on January, I think, 26th and 27th. Yep. Mm-hmm. So there's an Enroll Now button for that. Stephen, feedback to me on this, and Ben, if you would this be right for Ben as a novice, or would you suggest he take more of an introduction to PL SQL class first?
Yeah, I generally recommend for the best of class that you've got at least, the basics of PL SQL under your belt. Usually that doesn't take a whole long time, but if you truly are brand new to PL SQL, I imagine that you'd get more out of the class by doing an intro class first. I mean, if you really don't know the syntax, don't know the basic elements of the language. Most SQL developers who have been around in the Oracle space have at least a working knowledge of PL SQL. But yes, I would say that if you're truly completely brand new to the class, an intro class would be helpful first. Having said that, I definitely have people coming to my classes who are complete novices, brand new to PL SQL, and they still get an awful lot out of it. Just one more thing. Then if you are really needing to get up to speed from ground zero on PL SQL, I know it's kind of late, but the PL SQL training in Atlanta next week is a great way to do that. It's 2 days of nothing but PL SQL, and there's a whole fundamentals track. So you can take a combination of beginner stuff and dip your toes into more advanced stuff as well.
That's a great point. That's the 2-day OD Tug in Atlanta. And Stephen, you'll be there, of course, correct?
I will definitely be there, yep.
Great. And Ben, just finishing the answer to your question, there is a introduction to PL SQL. It's called the Oracle 11G PL SQL Programming Workshop on our calendar in December, and that's an online class. If you have a group of people and you'd like it at your audience, at your company, we'd be happy to bring it to you. So you have a couple options there. So that's it, I guess, for today's session. We very much hope that we see you in January 26th and 7th in Boston with Steven Feuerstein. It's going to be a great event. You'll receive a free copy of Oracle PL SQL Best Practices, of course, authored by Steven. So we're very excited for this offering to be near us in New England. And if you are in a different location, you want some PL SQL training, just shoot us an email. My email address is dave@skillbuilders.com, and we'll get that arranged for you as well. So I think that's about it for today. Thank you very much, Stephen. We appreciate your input. Looking forward to your class in January.
Thanks very much, and I look forward to seeing all of you. And again, don't hesitate to drop me an email if you have any questions or comments. All right. Take care, everybody. Happy Thanksgiving when it comes rolling along.
Thanks, Stephen. Talk to you soon.
Bye.